American wildfires have burned 1,918,000 acres. That number does not come from a cable news ticker. It comes directly from the National Interagency Fire Center, the federal agency that tracks every wildfire of consequence in this country. We have been sitting with that number for the last 6 hours, reading the reports, cross-checking the satellite data. Here is what that number means. The 10-year average for the same date is 1,085,000 acres. So right now, today, we are running 76% above the 10-year average, and peak fire season has not started. Peak season runs August through October. We are in May. 16 fires were burning with no containment line around them. 22 large fires are active across 13 states. On May 17th and 18th, the National Weather Service confirmed extreme fire weather conditions across the southern high plains, with winds gusting past 55 miles per hour and humidity dropping to 4%. 4%. The driest wood in your house right now is probably around 12%. The Sharpe Fire crossed from Oklahoma into Colorado on Sunday, May 17th. An entire town was ordered to evacuate. The fire burned more than 28,000 acres and sat at just 5% contained. Over 200 community members fought alongside firefighters to hold the line, and they held it. No homes were lost, but the Sharpe Fire is not the story. The story is the country behind it. 61% of the continental United States is in drought. 16 fires still have no containment, and the calendar says we have not even started the dangerous months yet. So here's the question nobody is asking on the evening news. If this is what May looks like, what does August look like? If you watched mainstream news the weekend of May 17th and 18th, you probably heard about the Sharpe Fire and the Campo evacuation. You probably did not hear that before a single day of peak fire season. This country has already burned 76% more land than the 10-year average of 1,085,356 acres. That number came from the federal government. It just did not make the headline. That is why this channel exists. We go to the official sources, we read the actual data, and we tell you what it says, not what is easy to fit into 30 seconds. If this is your first time here, hit subscribe. Every video on this channel is built the same way. Official sources, real numbers, no panic. Just the facts they buried past the headline. Drop a comment right now. Tell us where you are watching from and what time it is there. We want to know how many people watching this are inside one of these fire states this week. And here's the question for you. If you live in fire country, Texas, Oklahoma, Kansas, Colorado, New Mexico, do you have a plan for what you do if you have 15 minutes to leave? Tell us in the comments. Here's what the data actually says. The number we just read out is not a forecast. It is not a projection. It is not somebody's worst-case model. The number is 1,918,424 acres. That number is the official year-to-date wildfire total reported by the National Interagency Fire Center for the period ending May 15, 2026. The National Interagency Fire Center, which most people in this country have never heard of, is the federal coordination body that pulls fire data from every state, every federal land agency, and every tribal fire management office in the country. When NIFC reports a number, it is not an estimate from a single source. It is the consolidated record of every wildfire that grew large enough to be federally tracked. So when we say 1,918,424 acres, we are reading the receipt the federal government has already written. Take a slow look at that figure. 1,918,000 acres. That is more land than the entire state of Delaware. It is more land than Rhode Island. If you put it on the map of the country, it is a shape larger than some New England states combined. And that shape did not exist in January. It has been carved out of the country, one fire at a time, over the past 4.5 months. Every acre in that number is a place where grass, brush, fence line, ranch road, soil, or forest carried flame. Here is the comparison that matters. The 10-year average for the same date, January 1st through May 15th, is 1,085,356 acres. That is the average over the past decade. That number already includes the bad years. It includes 2020, when the West Coast burned. It includes 2024 when Texas had its largest wildfire in state history. The 10-year average is not the quiet year. It is the smoothed-out picture of a country that has been on fire for a long time. And we are 76% above that average. Look at the year-by-year comparison, and the picture sharpens further. On May 15th, 2023, the country had burned 473,908 acres. That is the recent baseline, 4 times less than where we sit today. On May 15th, 2024, the country had burned 1,853,502 acres. That was considered an alarming pace. On May 15th, 2025, the country had burned 1,087,958 acres, almost exactly the 10-year average. And on May 15th, 2026, the country has burned 1,918,424 acres. That puts 2026 ahead of 2024. It puts 2026 as the second highest figure on record for this date in the modern NIFC tracking era, beginning 1983, behind only 2017. Not the second highest of the last 5 years. The second highest in the modern record-keeping era. We are 3 weeks away from the start of summer. Behind that single acreage number sits another figure that almost nobody outside the fire community has read. 26,568 individual fires have been recorded in 2026 so far. That is the number of times something caught fire in this country, grew large enough to be federally reported, and required a response. It is not 26,568 campfires. It is 26,568 wildfire incidents. The 10-year average for ignition counts at this date is 18,893. So the country is also seeing 40% more starts than normal, on top of the 76% greater acreage. More fires, bigger fires, more land gone, all before peak season. Stretch the picture across the calendar. The U.S. wildfire system is built around the idea that the winter and spring months are the buildup. They are when crews train, when prepositioned aircraft are tested, when interagency agreements are signed for the season ahead. The summer months are when the real fight begins. Fire season in this country historically peaks August through October. Those are the months when the system expects to be stretched. Those are the months when the country mobilizes 30,000 personnel, dozens of aircraft, hundreds of engines, and pulls in mutual aid from Canada and Australia when the load gets too heavy. We are in May. The system has not even started its peak deployment, and the country has already burned almost double the normal pace. Texas is the state inside that national number doing the most lifting right now. The May 15th NIFC Situation Report listed 8 active large wildfires in Texas alone. On that single day, Texas reported 9 new ignitions. The state's combined active acreage from those 8 fires sat at 14,400 acres. Florida had 3 active large fires. Oklahoma had 3. New Mexico had 2. Nebraska had 2. Utah, Wyoming, California, and Colorado each had 1 large fire that was federally tracked. That is 22 large fires across 13 states. Some of those states are not states most people associate with serious wildfire. Florida, Nebraska, Utah. The fire footprint of this country in 2026 is wider than the West. It is the whole interior. Here is the analogy that lands the scale. Think about how far your car normally goes on a full tank. Think of it like this. Your car's gas tank. Normally you drive 300 miles before you need to stop and fill up. That is what you plan around. Now imagine you drove 530 miles and the gauge still says you have fuel. You would be checking the dashboard twice. Something changed, and if you do not know what, you might run out at the worst possible moment. That is what 76% above average means for wildfire acreage. The system is burning through its capacity faster than anyone planned for, and the hardest months have not arrived yet. Now layer in the timing piece. When fire managers plan for the year, they assume a certain ratio of springtime acreage to summer acreage. Spring is supposed to be a small share of the total. Summer is supposed to be the bulk. In a normal year, the country sits around 1 million acres in mid-May, then climbs to 4 or 5 million by late August, then can double or triple by the end of fire season. The shape of the curve is steep on the right side. What 1.9 million acres in May means is that the curve has already started climbing before the steep part begins. The shape changes, the slope is higher, and nothing about the underlying conditions, drought, fuel moisture, wind regime, snowpack, suggests the slope is going to flatten out. Federal land managers know what these numbers mean. The fact that nearly 2,000 personnel are already deployed to active incidents in mid-May tells us how the agencies are reading the data. 2,000 firefighters is not a small number for May. The system has not yet asked Australia or Canada for help. It has not yet pulled the largest categories of military aviation off other assignments. But it has activated the military airlift firefighting systems mobilization for 2026, and it has conducted emergency aerial firefighter training this spring. These are not the actions of an agency that thinks the next 4 months will be average. The number behind every number on this list is the one that frames the rest of the script. 1,085,000 acres is normal. 1,918,000 acres is where we are. The gap between those two numbers is 833,000 acres of fire that was not supposed to be on the map yet. And the country has 6 weeks before the calendar pushes us into the season this system was built to handle. That is the national picture. But a number this size does not come from nowhere. Something on the ground made it possible, and that something has been building quietly across more than half the country for months, confirmed by the federal drought map 6 days ago. Somewhere this week, a rancher in Texas is watching the sky the same way you watch a storm coming. If the country is already burning 76% above normal before a single day of peak season, what does the fire map look like when August actually arrives? The answer to that question begins with a single map. It is not the fire map, it is the drought map. The U.S. Drought Monitor is a joint product of the National Oceanic and Atmospheric Administration, the National Drought Mitigation Center at the University of Nebraska, and the U.S. Department of Agriculture. It is updated every Thursday. Land managers, ranchers, water utilities, and fire agencies read it the same way the rest of the country reads the weather forecast. The May 13th, 2026 release is the one we are looking at right now. And the picture it paints is the reason 1.9 million acres are gone. 61.47% of the lower 48 states are in drought. 51.35% of the entire United States, including Puerto Rico, is in drought. We need to slow down on those numbers because they are the foundation of everything else in this story. The lower 48 means the contiguous United States, every state except Alaska and Hawaii. 61% of that is in drought as of last Wednesday. If you drew a line across the continent at random, more than 6 out of every 10 miles you crossed would be land where the soil moisture, the stream flow, the vegetation health, or all three are below their long-term averages. That is not a regional story. That is a national condition. Inside that 61% figure there are categories. The Drought Monitor uses a scale of D0 through D4. D0 is abnormally dry. D1 is moderate drought. D2 is severe. D3 is extreme. D4 is exceptional. D4 is the highest category that exists on the federal scale. There is no D5. When an area is rated D4, it means soil moisture is at historic lows, surface water sources are at risk of failing, and vegetation is in a state where it cannot recover within a normal seasonal cycle. The Oklahoma Panhandle, where the Sharpe Fire started, is in D4. The entire Panhandle, not a corner of it, not a county within it. The whole strip of land that connects western Oklahoma to the Texas Panhandle to southwestern Kansas is at the highest drought category that the federal government measures. That detail is the answer to the question of why a fire that started in Oklahoma on Friday afternoon was big enough by Sunday to force the evacuation of a Colorado town. The land between Cimarron County, Oklahoma, and Baca County, Colorado, is a continuous ribbon of D4 drought. There is no moisture barrier between the ignition point and the structures the fire eventually threatened. There is no green band of pasture that would have slowed the flames. There is no creek bottom with damp vegetation. The corridor is dry from edge to edge. The NOAA Climate Prediction Center, which issues the monthly drought outlook, confirmed in its May 2026 outlook that this is not changing in the near term. The exact language in the outlook is that drought will persist across the high plains and portions of the west through the outlook period. Persist. That is the federal word for no improvement coming. The CPC does not write that word casually. When they say persist, they mean the modeling shows no significant rainfall events in the corridor, no return to seasonal humidity, and no recharge of soil moisture before the summer heat arrives. The drought map of May 13th is essentially the drought map of June, July, and August. Pile on the Colorado snowpack piece and the picture darkens. The winter of 2025 to 2026 produced one of the lowest snowpack readings on record for Colorado. Snowpack is the federal shorthand for how much water is held in the mountain snow that, in a normal year, melts gradually through April, May, and into June, flowing down into the soils and the streams of the plains below. That gradual melt is the moisture recharge that buffers the early summer against fire. It is the reason May in a normal year is not a fire month in this region. The grass has just greened up. The soil is still holding water, the creeks are running. None of that happened this year. The snowpack was meager. The melt was thin. The recharge did not arrive. By the time the calendar reached May, the land was already operating on the moisture profile of late July. Here is the analogy that holds the science. Dry grass burns differently depending on how much moisture is still in it. Here is what that actually means. A kitchen sponge. When a sponge is damp, you can hold a lighter to it and it barely catches. The moisture absorbs the heat. The fire goes out before it spreads. Now dry that sponge completely. Leave it on the counter for a week in the sun. Hold that same lighter to it. It catches immediately, it burns fast, and it does not stop until there is nothing left. That is what D4 drought does to grass across the Oklahoma Panhandle and southwest Kansas. The moisture that normally slows a fire down is gone. The fuel is cured and ready. All it needs is a spark. What most coverage did not mention was the drought number they were using was slightly off. Multiple outlets reported 62% of the country under drought. The U.S. Drought Monitor, the official joint product from NOAA, the USDA, and the National Drought Mitigation Center, shows 61.47% of the lower 48 as of May 13th. That is not a major error, but the more important gap was this. Almost no outlet explained what those drought categories actually mean. D4. Exceptional is not just dry, it is the point where land managers expect fire behavior to become extreme regardless of ignition source. The number was in the story. What it meant was not. Fine fuels are the formal name for the kind of vegetation that drives most of the fires in this region. Fine fuels are grasses, light brush, agricultural stubble, and small twigs. They cure quickly. They burn quickly. And the speed with which a fire moves through them depends almost entirely on their moisture content. The NIFC Predictive Services Group, which monitors fuel moisture levels across the country, reported in April 2026 that fine fuels across the eastern plains had reached historic dead fuel moisture minimums. Dead fuel moisture is exactly what it sounds like. It is the percentage of water still held inside vegetation that is no longer alive. A normal April reading for fine fuels in this region might be 12 to 15%. The April to 2026 readings were down to single digits in many places. Those are levels typically seen in late July and August, the peak of fire season. The fuel reached peak season readiness 4 months early. So here's the layered picture. The drought map shows the entire fire corridor at D4. The federal outlook says the drought will persist. The snowpack failed to recharge the soil. The fine fuels reached peak season dryness in April. And the long-term forecast offers no relief. The country is not waiting for fire conditions to develop. The conditions are already in place. Every fire from here to October is going to start in this set of conditions, not a normal one. The Texas Panhandle, which sits adjacent to the Oklahoma corridor, is in a similar drought state. The combined panhandle region of Texas and Oklahoma represents one of the densest D3 and D4 zones in the country right now. New Mexico's eastern grasslands, which feed into the same wind corridor that drives the fires, are also in drought. So is most of southwest Kansas, southeastern Colorado, and a strip of southwestern Nebraska. These are all federal designations. They are not opinion. The drought is a measured condition with a number attached. The Federal Climate Prediction Center also publishes a 3-month outlook that projects probability of above normal, below normal, or near normal precipitation. For the May through July window in the southern high plains, the outlook leans toward below normal precipitation. That means the rain that might have arrived in late May or June, the rain that historically can break a regional fire weather pattern, has a reduced probability of showing up at all. In drought language, that means the existing dry conditions are likely to intensify rather than ease in the near term. There is one more piece that the maps do not always show: the relationship between drought and wind. In a normal moisture year, even a windy day in the southern high plains does not produce extreme fire weather, because the vegetation is too damp to carry flame at the speed wind can push it. In a D4 drought year, every windy day becomes a fire weather day. The wind does not change. The fuel changes. The danger comes from the combination of an already dry landscape and the routine wind patterns of the region. The southern high plains have always been windy. Cattle ranchers have known that for 150 years. What is different in 2026 is what the wind is moving through. Federal land managers in the affected states have been quietly elevating their risk language for weeks. The Bureau of Land Management offices in New Mexico, the National Park Service in Colorado, and the U.S. Forest Service in Kansas have all been issuing advisories about fuel moisture conditions, ignition restrictions, and the heightened state of readiness. These advisories do not make the evening news. They sit on agency websites. But they describe a system that has been bracing for what it expected might come and what arrived on May 15th in Cimarron County, Oklahoma. The drought set the table. The ground was ready. And on May 15th in Cimarron County, Oklahoma, the trigger came. What happened over the next 72 hours is why an entire Colorado town had to leave in the middle of a Sunday afternoon. Right now, more than 61 out of every 100 miles of American land is in drought, and most of it is in fire country. The drought map looked like this in May. The fire season does not peak until August, and NOAA says the drought is not going away. So what exactly does the fire map look like when those two things meet? The trigger on May 15th came in Cimarron County, Oklahoma, which sits at the very western tip of the Oklahoma Panhandle. It is the only county in the state that touches both New Mexico and Colorado. The population of the entire county is approximately 2,200 people, spread across 1,841 square miles of ranching, grassland, and dry farms. It is one of the least densely populated counties in the lower 48 states. When a fire starts in Cimarron County, the people who first see it are usually the ones who live nearest to where it started, and the closest firefighting resource is often a volunteer crew from a town 30 or 40 miles away. The Sharpe Fire was first reported in the early morning hours of Saturday, May 16, 2026, at around 5:30 a.m. local time, though it ignited the previous evening on Friday, May 15th. Within hours, it had grown beyond the capacity of local response. By Saturday, it had crossed county lines. By Sunday afternoon, May 17th, it had crossed the Oklahoma-Colorado state line into Baca County, Colorado, a county whose entire population is approximately 3,375 people. The fire was now an interstate incident. 2 governors, 2 state emergency management offices, 2 state fire marshals, and a dozen volunteer departments were now coordinating on a single fire footprint. As of Monday morning, May 18th, the official figures from Baca County Office of Emergency Management and the Colorado Sun put the Sharpe Fire at 28,200 acres in total, with approximately 18,000 of those acres in Colorado. Containment stood at 5%. That number is what fire crews use to describe how much of the fire perimeter has a hard line around it, a line that has been cleared down to bare soil or wetted down enough that the fire cannot cross it. 95% of the Sharpe Fire's perimeter on Monday morning was still open. That meant the fire could expand in any direction at any time, depending on wind shifts and fuel availability. On Sunday evening, May 17th, Colorado Governor Jared Polis verbally declared a state of disaster emergency. That declaration is the legal mechanism that releases state resources, activates the National Guard if needed, and allows expedited mutual aid agreements with neighboring states. The declaration was issued because the entire town of Campo, Colorado, a small ranching community in Baca County, was placed under mandatory evacuation. Campo has a population of approximately 97 people, small enough that most residents know each other by name. When the alert went out at 2:06 p.m. on Sunday, May 17th, people had minutes, not hours, to decide what to take with them. Here is the detail that matters most about how grass fires move in this kind of fuel and weather. The National Weather Service fire safety guidance is clear that in grass fire conditions, the evacuation window can be as little as 15 minutes from the moment a fire ignites to the moment it reaches a structure. 15 minutes. That is not an estimate. That is the confirmed window in NWS materials used by every emergency management office in fire country. 15 minutes is the time it takes to brush your teeth, make a cup of coffee, and pour it into a thermos. It is the time it takes to drive across a small town. It is not the time it takes to pack a vehicle, gather pets, find documents, and get out of a rural property with one paved road of egress. 15 minutes is also not the buffer that grass fire embers respect. The federal fire research literature documents that in grass fire conditions, embers from the active fire front can travel up to 1 mile ahead of the visible flame. That means a structure can be threatened by ember-driven ignition before the main fire is even visible on the horizon. A homeowner watching a smoke column 10 miles away may believe they have hours to decide. The embers from that fire may already be landing on the dry grass between their house and the front. By the time the flame arrives, the ground beneath the structure may already be burning. The satellite data on the Sharpe Fire gives us a way to measure how intense it actually was. GOES 19 is the new generation geostationary weather satellite operated by NOAA. It carries an instrument package that can detect thermal signatures from active fires. The detector has an upper measurement limit. The technical term for that limit is saturation. When a fire is hot enough that the satellite cannot measure higher, the reading saturates at the maximum, which is 137.77 degrees Celsius at the wavelength used for fire detection. On May 17th at 2017 UTC, which is 4:17 p.m. Eastern Daylight Time, the GOES 19 thermal channel saturated over the Sharpe Fire. The Cooperative Institute for Meteorological Satellite Studies blog confirmed the reading. What that tells us is that the fire was burning at an intensity at or beyond what the satellite was designed to measure from space. Saturation does not happen with routine fires. It happens with fires that are putting energy into the atmosphere at industrial scale. The terrain of the Sharpe Fire footprint is important to understand because it shapes how the fire moved. Baca County, Colorado, is the southeastern corner of the state. It is not the Rockies, it is the high plains. The landscape is rolling grassland, sage flats, ranch roads, scattered cottonwood stands along the dry creeks, and small irrigated fields. There are very few natural fire breaks. The terrain offers almost no slope to slow a fire down, and the wind that pushes the flame faces almost no obstruction. When a grass fire ignites in this country and the wind is from the southwest, the fire can run for tens of miles before it hits anything that meaningfully changes its behavior. Highway 2. 87 is the primary north-south highway through this region. It is the road residents of Campo would take to evacuate north toward Lamar or south into Oklahoma. On Monday, May 18th, the southbound lanes of Highway 287 between Springfield and the Oklahoma state line were closed due to smoke and visibility, then later reopened as conditions improved. The Colorado Department of Transportation maintains real-time highway status at cotrip.org. When you live in a county with one major paved road and the road closes, your options narrow dramatically. The closure also affected supply chain access for firefighting crews who depend on tankers, food, water, and equipment moving along that corridor. Despite the conditions, the Campo evacuation ended better than it could have. By 11:30 p.m. Sunday night, the evacuation orders were lifted. The reason they were lifted is the part of the story that almost no national outlet told in full. Over 200 community members showed up to fight the fire alongside professional crews. Ranchers brought their tractors. Volunteers brought water trucks. Local fire departments arrived from adjacent counties. People who lived in Campo did not just evacuate and wait. Many of them turned back with whatever equipment they had, and they helped hold the line through Sunday night and into Monday. No occupied homes were lost. That outcome is not a guarantee for the next fire. It is a story about a specific community on a specific weekend, and it depended on conditions holding inside a tolerable range. The wind on Sunday afternoon in Baca County was sustained at around 25 to 35 miles per hour, with gusts confirmed at 40 to 47 miles per hour by RAWS, weather stations upstream of the fire. If those gusts had been 10 miles per hour stronger, the fire's rate of spread could have doubled. Crews would not have been able to hold the line. Equipment that was being run safely at one wind speed would have been unsafe at another. Aerial firefighting, which had been grounded earlier during the Ranger Road fire when gusts exceeded 65 miles per hour, would have been grounded again. And a community of approximately 97 people in a county of 3,375 would have been making decisions in a different operating environment. The named expert voice on the Sharpe Fire that gave the situation its clearest framing was Baca County Sheriff Aaron Shiplet, who confirmed during the Sunday afternoon evacuation that the fire had moved faster than initially anticipated and that residents had a narrowing window to act. What he was saying in plain English was that the fire's behavior had outpaced the planning assumptions that had been made earlier in the day. What the data shows that he did not say, because no operational official will say it during an active incident, is that the planning assumptions were based on wind forecasts that themselves were updated in near real time as the fire moved. The reason the response worked is that the wind held within the predicted envelope. Had it shifted by 10 miles per hour in the wrong direction, the planning assumptions would have failed. What the Sharpe Fire confirms about the broader system is the proximity of communities to fast-moving fuel beds. Baca County, like Cimarron County across the line, like the rural counties of southwest Kansas, like the Texas Panhandle counties, is built around small towns connected by long stretches of dry grass. Every one of those small towns sits in the path of a potential grass fire. Every one of them has the same kind of 15-minute evacuation profile. Every one of them has the same kind of single-road dependency. The Sharpe Fire was the example this weekend. The geography contains hundreds of similar examples. The Southwest Kansas Fire Corridor, which includes Clark, Ford, Harper, Meade, and Morton counties, has a combined population of approximately 42,000 people. That corridor saw 17 grass fires in the 72 hours surrounding the Sharpe Fire ignition, driven in part by dry lightning from the same weather system. The Storm Prediction Center issued an extreme fire risk rating of level 3 of 3 for parts of that area on May 18th. Level 3 is the maximum SPC issues for fire weather. It is not a routine designation. The corridor was operating under the highest possible federal fire weather rating, at the same time the Sharpe Fire was burning across the state line. Texas Panhandle communities sit in the same situation. The Amarillo metropolitan area, with a population of approximately 314,000 people, was 29 miles southeast of the Blue Diamond Fire, which was one of the 8 active Texas fires. The Texas Panhandle was operating under red flag warnings throughout May 17th and 18th, with humidity at 4% and wind gusts confirmed at 55 miles per hour by NWS Lubbock. A red flag warning means that critical fire weather conditions either exist or will exist within 24 hours. It is the highest level of operational fire weather alert the NWS issues. In Texas, on May 18th, that warning covered the Panhandle, the South Plains, and the Rolling Plains. The exact NWS language read, "Any fires that develop will spread rapidly. Outdoor burning is not recommended." Campo held. Over 200 people fought alongside professional crews and no homes were lost. But the Sharpe Fire, sitting at 5% contained, is not an isolated event. It is the third time this exact corridor produced a major fire emergency in 2026. and the first two were far bigger. Over 200 people from that community showed up to fight a fire through the night so their neighbors could come home. The fire gave people 15 minutes. The highway closed behind them due to smoke. The satellite recorded the highest possible heat reading at 2017 UTC on May 17th. And the question nobody can fully answer is, if the wind had been 10 miles per hour stronger that Sunday afternoon, how many of those 200 people would have been able to hold that line? To answer that question, we go back 91 days. The Ranger Road Fire ignited in the Oklahoma Panhandle on February 17th, 2026. It is the same corridor where the Sharpe Fire would later start. It is the same kind of country, the same kind of fuel, the same kind of wind. And it is the case study that fire managers across the southern high plains have been using to plan for the rest of 2026. The Ranger Road Fire reached 15,000 acres within 1 hour of ignition. That sentence is not a typo. 1 hour. Within 9 hours, it had grown to 145,000 acres. By the time it was finally controlled, it had burned 283,283 acres across Oklahoma and Kansas. The fire was driven by wind gusts that fire officials reported exceeded 65 miles per hour at peak. Aerial firefighting, which is one of the most important tools the United States has for slowing the spread of large grass fires, was grounded when those gusts exceeded the safety threshold for tanker aircraft. Crews on the ground watched the fire run. The numbers in that sequence deserve to be read slowly because they describe what is physically possible in this terrain under conditions that are no longer rare. 15,000 acres in 1 hour. That works out to 250 acres per minute. That is more than 4 acres per second. A fire running at that pace is not a fire that anyone fights at the head. It is a fire that crews work the flanks of, and they pray the wind shifts before the head of the fire reaches anything that cannot be replaced. The Ranger Road Fire happened in February, which is the part of the story that fire researchers cannot stop returning to. February is not fire season. February, in the southern high plains, is supposed to be the time when grass is still partially dormant, when fuel beds are thinner, when overnight temperatures drop low enough to slow combustion. The Ranger Road Fire ignored all of that. It ran in February as if it were August. The Morill Fire is the second precedent, and it is the bigger one. The Morill Fire ignited on March 12, 2026 in western Nebraska. It traveled 70 miles in 12 hours. It ultimately burned 643,361 acres. It is now the largest wildfire in Nebraska state history, and it is larger than the second largest fire in Nebraska history, which burned 289,000 acres and the third largest combined. The Morill Fire was driven by sustained winds of 20 to 35 miles per hour with humidity at 15 to 20%. Those are the conditions that produced the worst fire in Nebraska's recorded history. Compare those conditions to what the National Weather Service confirmed in the southern high plains on May 17th and 18th, 2026. Wind gusts past 55 miles per hour. Humidity at 4%. The conditions this past weekend were more extreme than the conditions that produced the largest wildfire in Nebraska history. The fire that burned 643,361 acres in March did so under a calmer atmosphere than what the Texas Panhandle has been operating under from May 15th through May 18th. Both the Ranger Road Fire and the Morill Fire happened before spring greenup. In the southern plains, the period from late February through mid-April is the seasonal window when last year's grass is fully cured, but this year's grass has not yet greened up. Fuel managers consider that window dangerous because the fuel bed is uniformly dry, but it is also a window when the fuel load itself is at its lowest. The grass that drove those fires was thin, last year's leftover scattered in patches. The grass that would drive a fire today in May is denser. The 2025 grass is still there because the drought never let it decompose. The 2026 grass has grown on top of it. The fuel bed is now layered. It is also more continuous. The named expert voice on this dynamic is Dr. Brian Potter, a fire meteorologist with the U.S. Forest Service Pacific Wildland Fire Sciences Laboratory, who has spent his career studying the interaction between weather and fire behavior in plains environments. Researchers like Dr. Potter and his colleagues have consistently documented that the highest risk fire windows in the southern high plains occur when three conditions align: low humidity, high wind, continuous cured fuel. What he and his peers have been saying in their published work in plain English is that the southern plains have evolved into a region where those three conditions can align outside of traditional fire season. What the data shows that the published research has not yet fully articulated, because the science moves slower than the climate, is that 2026 is the year that alignment has stopped being a seasonal event and started being a year-round risk. The geographical continuity between the Ranger Road Fire, the Morrill Fire, and the Sharpe Fire is the part that should keep anyone who lives in this corridor awake at night. The three fires occurred in a relatively narrow strip of country that runs from the Oklahoma Panhandle north through southwestern Kansas and into western Nebraska. That strip is essentially a single fire ecosystem. It has the same fuel type, the same wind regime, the same drought profile, and the same population density. 3 major fires in 91 days in the same strip is not 3 coincidences. It is a pattern. The NIFC Predictive Services Group, which is the federal team tasked with looking ahead at fire potential, classified the southern high plains as above normal significant fire potential for May 2026 in its monthly outlook. That classification means the team expects more large fires than the historical average for the month. Above normal is one step below much above normal, which is the highest category. The outlook released by NIFC for May was issued before the Sharpe Fire ignited. It was already calling for what is now unfolding. What makes today different from February and March is also a measurement that does not appear in any single news report. The NWS Amarillo office, which serves the Texas Panhandle, confirmed a fire environment rating of 9 out of 10 for the southern high plains on May 17th. The fire environment rating is a composite measure that combines fuel moisture, wind, humidity, temperature, and atmospheric stability into a single index. A rating of 9 is one notch below the maximum possible. It is the kind of rating fire offices issue when they expect any ignition to grow rapidly and resist initial attack. The aerial firefighting consideration is the single most consequential aerial resource consideration of the Ranger Road comparison. When the Ranger Road Fire was at its peak spread, the wind gusts exceeded the operational limit of large air tanker aircraft, which is generally in the 60 to 65 miles per hour range. Tanker pilots cannot fly safely into wind shears above that range, so the most powerful tool in the federal arsenal, the very large air tankers and the C-130s with MAF systems, was grounded. Crews on the ground watched the fire move and could only work the flanks. The same scenario could have unfolded on the Sharpe Fire if Sunday's gusts had pushed past 60 miles per hour. They did not. They held at the high 40s and low 50s. That margin is the only reason Compo's evacuation ended the way it did. Both the Ranger Road Fire and the Morrill Fire eventually went out, but neither of them went out because crews put them out. They went out because the wind changed, because the fuel ran out at the edge of a different fuel type, or because the atmospheric profile shifted. Modern fire management has tools, but in grass fires of this magnitude, the tools support the fire's natural deceleration. They do not produce it. That is the operational reality that does not appear in press conferences, but is well understood by every fire manager in the region. The fuel piece is where the May comparison to February and March turns most uncomfortable. The Ranger Road Fire ran through cured but sparse fuel. The Morrill Fire ran through cured but sparse fuel. A fire starting today in the same corridor would run through cured and dense fuel, because the spring growth that has occurred under drought has not added moisture, only added biomass. Range scientists call this loading. Higher fuel loading means more energy released per acre, more intense heat plumes, more ember production, and more difficulty for crews working close to the flame. There is a specific number that captures how the fuel availability has changed. The NIFC Predictive Services Group reported in its April fuels assessment that dead fuel moisture content in fine fuels across the eastern plains had reached values typically seen only at the peak of fire season in late summer. The number was in the single digits in many measurement plots. For comparison, the Ranger Road Fire in February ignited in fuels that had dead fuel moisture around 8 to 10%. The May 2026 readings are at or below that. The Sharpe Fire ignited into a fuel bed that was, by measurement, even drier than what the Ranger Road Fire ignited into. Stack the three fires up against each other on a single line. Ranger Road, February 17th. Oklahoma Panhandle, 283,283 acres. Wind gusts past 65 miles per hour. Fuel moisture in the high single digits. Evacuation timelines around 30 minutes. Morill, March 12th. Western Nebraska, 643,361 acres. Sustained winds 20 to 35 miles per hour with gusts higher. Humidity 15 to 20%. Evacuation timelines around 20 to 30 minutes. Sharpe, May 15th. Oklahoma to Colorado, 28,200 acres so far. Gusts in the high 40s to low 50s. Humidity as low as 4%. Evacuation timeline confirmed at 15 minutes for grass fire conditions. The Sharpe Fire is smaller than the other two so far. The conditions that surround it are at least as severe, and in some categories more severe. The fuel managers reading these numbers know what they mean for the months ahead. The historical pattern in this region is that fires get larger and more frequent as the calendar moves from May into June, July, and August. The peak fire activity window for the southern high plains and central plains typically falls in late summer. If the May fire activity is already running at peak season fuel readiness, the summer activity does not have anywhere to go but higher. What the data also shows, which most coverage of the Ranger Road and Morill fires did not articulate, is that those two precedents are not standalone events. They are part of a regional fire regime that is shifting. Researchers at the University of Nebraska and at Kansas State have been publishing for several years on the increasing frequency of large fire events in the Central Plains, with the trend line moving steadily upward through the 2020s. The 2026 fires fit that trend. They are not outliers. They are the trajectory of the regime. So the pattern is documented. The same region, the same fuel type, the same wind regime. Twice in 91 days. But here's what makes this week different from February and March. The fire was not the only thing happening. The exact same weather system was doing something completely different, 400 miles to its northeast, and the National Weather Service documented both in the same forecast. The Ranger Road Fire went from 15,000 acres to 145,000 in 9 hours. Someone was watching that happen in real time with nothing they could do to stop it. The Ranger Road Fire needed 9 hours to reach 145,000 acres, under conditions that were less extreme than what the southern high plains recorded on May 17th and 18th. The question is, if a new major ignition happens during the next fire weather window, does it move faster or slower than the Ranger Road Fire did? The forecast document that connects all of this is the National Weather Service Weather Prediction Center Short-Range Forecast Discussion, issued at 3:32 p.m. Eastern Daylight Time on Monday, May 18th, 2026. The forecast is valid from 00 Zulu May 19th through 00 Zulu May 21st, covering the window from 8 p.m. Eastern Monday through 8 p.m. Eastern Wednesday. It is one document, 48 hours of weather, and inside it, the NWS identified 4 separate categories of active hazard, all driven by the same system, all unfolding at the same time across the country. The exact agency language matters here because the precision of the wording is what tells us how the forecasters were reading the situation. The NWSWPC wrote that there were extreme fire weather concerns across the southern high plains through Monday evening. They wrote that severe weather and flash flooding threats would continue across the central plains and Midwest into Monday night. They wrote that an early season heat wave would challenge temperature records across the eastern U.S. through Wednesday. And they noted heavy wet snow in the central Rockies in the same forecast window. Fire, tornadoes, flooding, heat, snow, 5 active hazards. One forecast document. The Storm Prediction Center, which is the NWS office that handles severe thunderstorm and tornado outlooks, issued a level 4 of 5 severe thunderstorm risk on May 18th for an area covering central Kansas to northwestern Missouri. Level 4 out of 5 is rare. The SPC issues that level approximately 14 days per year nationally. Not 14 days in fire country, not 14 days in Tornado Alley, 14 days nationally. Days. So when a level 4 is issued, it represents one of fewer than 24 days a year when conditions are bad enough to warrant that classification. On May 18th, the Level 4 zone covered an area that included Wichita, Topeka, Kansas City, and the corridor stretching into Iowa. Inside that Level 4 zone, the SPC also issued a particularly dangerous situation tornado watch for northeast Kansas and southeast Nebraska. A particularly dangerous situation tornado watch is a special designation that the SPC reserves for conditions when forecasters believe there is significant potential for violent, long-track tornadoes, the kind that can produce EF3, EF4, or EF5 damage. Most tornado watches are not particularly dangerous situation watches. When that designation is used, it is a signal to local emergency managers that this is not a routine watch period. The population inside the Level 4 severe weather zone on May 18th, according to CNN reporting and SPC mapping, was approximately 4.5 million people. That count covered Omaha, Kansas City, Des Moines, and parts of the Chicago corridor. 4.5 million Americans were under one of the most serious severe weather risk categories the federal government issues. On the same day that 4% humidity and 55 miles per hour winds were driving the Sharpe Fire deeper into Baca County, Colorado. The two events were not unrelated. They were the same weather system expressed differently across geography. Here is how the mechanism works in physical terms. Picture the central United States on May 18th. A slow-moving cold front, anchored to a strong low-pressure system, was draped diagonally across the country from the Rockies through the upper Midwest. On the southwest side of that front, the air mass was hot, dry, and downsloping, which means the air was descending from higher terrain and warming as it dropped. Descending air loses moisture. As the air moved across the southern high plains, the humidity dropped into the single digits, and the temperatures rose into the upper 80s and low 90s. Wind speeds accelerated as the pressure gradient between the front and the high-pressure system to the south tightened. That is the recipe for extreme fire weather. Dry, hot, fast wind. On the northeast side of the same front, the air mass was completely different. Moist air was being pulled northward from the Gulf of Mexico. That moisture pooled along the front. Where moist air met the boundary between the two air masses, the atmosphere became unstable. Thunderstorms began to form along the front. The vertical wind shear, which is the difference in wind speed and direction with height, was high enough to support rotating supercell thunderstorms. Supercells produce tornadoes. The combination of moisture, instability, and wind shear was the recipe for severe weather and tornadoes. Here is the analogy that holds the science. One weather system can create completely opposite conditions depending on which side of it you are standing on. Think of it like this. A ceiling fan running on high. Stand directly under it. You feel wind coming straight down at you. It is drying, it pushes air fast. If the room is already dry, that air makes everything drier. Now walk to one side of the fan and hold a damp towel into the airflow coming off the blade tips. That same fan is now picking up moisture and moving it somewhere else. On one side, drying. On the other, moisture transport. That is what this cold front did across the central United States. On its southwest side, drying, heating, 55 miles per hour winds into fire country. On its northeast side, pulling Gulf moisture northward and feeding supercell thunderstorms capable of EF3 tornadoes. Same system, completely different outcomes depending on which side of it you live on. The data tells a different story than the headline. On May 17th and 18th, fire coverage and tornado coverage ran as completely separate news stories. Multiple outlets reported the tornado outbreak with no mention of the fire warnings. Multiple outlets reported the Sharpe Fire with no mention of the simultaneous tornado threat. The NWSWPC did not separate them. Their May 18th forecast named both hazards in the same document as products of the same system. When you report fire and tornadoes as separate stories, you give people the impression the country is dealing with two manageable problems. When you read the forecast document they came from, you see one system creating simultaneous emergencies across a 1,000-mile stretch of the country at the same time. The flash flooding piece is the third hazard, and it was issued by the NOAA Weather Prediction Center at 4:28 p.m. Eastern Daylight Time on May 18th as a moderate risk of excessive rainfall for parts of Missouri, Iowa, Nebraska, and Kansas. Moderate risk is the second highest category the WPC issues for rainfall. It indicates that flash flooding is likely in vulnerable areas. The same supercell storms that were generating tornadoes were also producing rainfall rates capable of overwhelming small streams, urban drainage systems, and low-lying agricultural areas. So in the same counties where tornado warnings were going off, residents were also being warned about flash flooding from the same storms. The named federal voice that pulled this all together that afternoon was the senior forecaster on duty at the NWS Weather Prediction Center, whose product appears in every forecast discussion as the lead author. The product itself is the agency's voice. What the WPC was saying in plain English is that the country was about to experience a multi-day stretch in which one weather system would produce simultaneous emergencies across 4 different hazard categories. What the data shows that the forecast did not state outright, because federal forecasts are written in measured language, is that the simultaneous multi-hazard scenario is the kind of stress test that exposes weaknesses in the emergency response system. When fire crews in Colorado, tornado spotters in Kansas, flood managers in Iowa, and heat response coordinators in Pennsylvania all need attention at the same time, the federal coordination structure has to triage. Inside the fire corridor on the southwest side of the front, the operational picture matched the WPC forecast precisely. The NWS Lubbock office, which serves the Texas Panhandle, issued a red flag warning at 12:48 p.m. Central Daylight Time on May 18th. The warning was valid through 10 p.m. Central. The exact conditions listed were southwest winds 25 to 35 miles per hour with gusts to 55 miles per hour, and relative humidity as low as 4%. The NWS Albuquerque office issued a similar red flag warning at 1:36 a.m. Mountain Daylight Time on May 18th for multiple New Mexico zones, with southwest winds 25 to 35 miles per hour and gusts of 50 to 55 miles per hour or higher, and relative humidity of 5 to 15%. The exact NWS language on both warnings was the same. Any fires that develop will spread rapidly. Outdoor burning is not recommended. Inside the tornado zone on the northeast side of the same front, the Storm Prediction Center was tracking individual supercells through the afternoon and into the evening. The first tornado warnings began to come down in central Kansas in the early afternoon and pushed eastward through the day. Multiple tornadoes were reported. The exact damage tallies and the full count of confirmed tornadoes from May 18th were still being finalized by NWS storm survey teams as of May 19th. What was not in dispute was the scale of the threat. The Level 4 designation, the Particularly Dangerous Situation Watch, and the 4.5 million person population inside the risk zone all confirmed what the forecast had laid out hours earlier. The compound nature of the event also extended into the third dimension. While fires burned in the south and tornadoes spun in the middle of the country, the same forecast confirmed heavy wet snow in the central Rockies. Snow in May. In the same 72-hour window as 4% humidity and EF3 tornadoes. The Rockies' snow was driven by upslope flow on the backside of the cold front, where moist air was being lifted by the terrain and cooled to the point of producing wet snowfall at higher elevations. The result was a country experiencing fire, tornadoes, flooding, heat wave, and snow all simultaneously across a single 48-hour forecast window. There is no historical precedent for that exact combination at this scale, this early in the calendar year. The emergency response implications of this kind of compound event are profound. Federal resources, particularly in aviation, in mobile incident command, and in specialized response teams, are not infinite. When fire requires aerial tankers in Colorado, severe weather requires storm survey teams in Kansas, flooding requires swiftwater rescue teams in Iowa, and heat requires utility load coordination in the Northeast. The same coordination centers, the same dispatchers, the same federal liaison officers are involved in routing decisions. A single major event in one of those categories is what the system was designed to handle. 4 simultaneous major events stretch the structure. 1 weather system, 4 active hazards. Fires in the south, tornadoes in the middle, flooding to the north, heat building on the east coast. That eastern heat wave, the one that seems farthest from the fire story, actually connects back to the fire in a way that most coverage missed entirely. While people in Kansas were watching tornado warnings on their phones on May 18th, people in Oklahoma were watching that same front-push smoke across their property lines. So here's the open loop. One weather system produced fires, tornadoes, flash floods, and a heat wave simultaneously on May 18th. The question that generates is this. When emergency systems in Kansas, Colorado, Oklahoma, and Missouri all needed resources at the same time, which call got answered first? The piece of this story that has barely been touched in the public conversation is what was happening on the East Coast at the same time. The NWSWPC May 18th forecast confirmed an early season heat wave that would challenge temperature records across the eastern United States through Wednesday. That heat was not random. It was not a separate weather event. It was the eastern half of the same system that was producing fires in the southwest and tornadoes in the middle. The mechanism that linked them was a ridge of high pressure parked over the eastern United States. A high-pressure ridge in atmospheric terms is a column of sinking air. The air column rotates clockwise. It pushes other systems around it. When a ridge sits over the eastern United States in May, it does several things at once. It blocks Atlantic moisture from moving inland. It traps warm air underneath it, which compresses and heats further. And it pushes the jet stream northward and westward, forcing storm systems to track around the edge of the ridge rather than through it. The jet stream is the river of fast-moving air at high altitude that steers weather systems. When the ridge moves the jet stream north, storms that would normally cross the country in a more orderly pattern get pushed to the edges. That is what created the slow-moving cold front in the plains. The ridge over the east was the reason the front in the west stalled out long enough to produce 96 hours of extreme fire weather. So, the eastern heat wave was not a parallel story. It was the structural reason the fire weather lasted as long as it did. The same ridge that was forcing temperatures into record territory in Philadelphia, New York, and Washington was also forcing the cold front behind the fire weather to slow down and intensify. If the ridge had not been there, the front would have moved through faster, and the fire weather window would have closed sooner. The ridge held the door open. The heat on the East Coast through May 18th to May 20th was projected to challenge temperature records for the date in multiple cities. The NWS used the specific language of challenging records, which is the federal way of saying that forecasters expected highs to come within a few degrees of historical daily maxima. Early season heat waves are particularly dangerous for a reason most people do not think about. They arrive before the body's seasonal acclimatization has occurred. The human body adjusts to heat over the course of weeks. In May, before the country has been through a sustained warm period, that adjustment has not happened yet. So an early season heat wave produces more heat-related emergency room visits per degree of temperature than the same heat would in August. The same logic applies to the electricity grid. Power utilities across the United States manage their summer peak demand starting in late June, when air conditioning load reaches its annual maximum. Before that, the grid is in a transitional configuration. Maintenance work is being completed on transmission lines. Power plants are coming online from spring outages. The grid is not yet running at full peak readiness. When an early season heat wave drives air conditioning demand to summer peak levels in May, the grid has to scramble to meet the demand. That is exactly the condition under which outages become more likely. The grid is not unready, it is in transition, and the demand arrives before the transition is complete. Across the eastern PJM interconnection territory, which is the regional grid operator serving more than 65 million people from New Jersey through Illinois, demand on May 18th climbed into ranges normally seen in late June or early July. PJM did not issue a system emergency, but the demand profile that day was an early season test. The grid passed, but the test was real, and it came from the same atmospheric configuration that was fanning the Sharpe Fire. The connection between the heat wave and the fire is also a temporal connection. The eastern heat wave was forecast to break by late week, when the cold front finally pushed through the Appalachians and out into the Atlantic. That is the same front that was driving fire weather in Oklahoma, Kansas, and Colorado. When a front like this moves, it does not stop being dangerous. It just moves the danger. The front's passage over the east would bring relief from the heat. The same front's passage over the fire states would not bring relief. It would bring wind shifts, possible dry lightning, and a new pulse of unstable atmospheric conditions over land that is already drought-cured and burning. Dry lightning is the term for cloud-to-ground lightning strikes that occur during thunderstorms, where the rain does not reach the ground. The rain evaporates in the dry air column below the cloud base, but the lightning still reaches the surface. Dry lightning is one of the most consequential ignition sources in fire country. A single dry lightning event in southwest Kansas in early May ignited 17 grass fires in a 72-hour window. As the front continues to move and as the atmosphere remains unstable across the fire corridor, the probability of new dry lightning events stays elevated. The historical context for this calendar window is important. The single most active week for tornadoes in U.S. recorded history is the week of May 19th through the 26th. Researchers at the Storm Prediction Center have documented this for decades. The combination of warming continental temperatures, persistent Gulf moisture, and active jet stream patterns produces more tornado-favorable conditions in that 1 week than in any other week of the year. That climatological window aligns precisely with the fire weather window that is currently active. So the country is moving into the most tornado-prone 7 days on the calendar, while simultaneously running the highest acreage fire pace it has seen in nearly a decade. The compound risk implications of overlapping climatologies are not theoretical. They affect specific operational decisions. The Federal Emergency Management Agency, which is the federal coordinator for major disaster response, allocates prepositioned resources based on forecast probabilities. When the forecast says fire here and tornadoes there, the allocation is geographically distributed. When the forecast says fire and tornadoes and flooding and heat all at once, the allocation has to be made under conditions where every region is asking for resources at the same time. The agency's playbook for this is well developed, but the playbook has limits. The limits are not in the planning. They are in the physical inventory of trucks, helicopters, generators, water tankers, and trained personnel. The grid stress dynamic is also a piece of the compound picture that connects east and west. When the eastern grid runs hot, generation reserves get pulled from neighboring regions if the interconnections allow. The Midwest grid, which serves much of the tornado zone, was simultaneously experiencing severe weather that took transmission lines offline and damaged substations. When two grid regions are stressed at the same time, the buffer that one region normally provides to the other shrinks. This is not a fire story, but it is a story about how the same weather system can create stress in unrelated systems simultaneously. The exact words from the named federal voice that brought the Eastern piece into focus came from the NWS Weather Prediction Center senior forecaster product issued at 3:32 p.m. Eastern on May 18th. The line was clean. An early season heat wave will challenge temperature records across the eastern U.S. through Wednesday. What that meant in plain English was that the heat dome had locked in and was not moving. What the data shows that the forecast did not say outright is that the heat dome was a structural feature, not a passing event, and its persistence had downstream consequences for the fire weather hundreds of miles to the west. The Rockies snow piece also connects to this set of dynamics. As the cold front moved into the Rockies, the upslope flow on its backside produced heavy, wet snow at higher elevations. Heavy, wet snow in May at elevation is not unusual. What is unusual is the simultaneous combination of snow at elevation, fire at the surface in adjacent geography, tornadoes 400 miles to the east, flooding overlapping with tornadoes, and heat to the east of that. The atmospheric profile that produced all 5 of these features is one of the most complex compound configurations the country has seen this early in the calendar year. The consequences of this kind of simultaneous multi-region stress fall hardest on people who live in the seams between regions. A rancher in southwest Kansas was inside both the fire weather risk zone and the severe weather risk zone on May 18th. The same property was at risk of fire from the southwest and at risk of tornadoes from the northeast on the same day. There are no operational playbooks for that scenario at the household level. The advice you would receive from your local emergency management office for a fire risk is different from the advice you would receive for a tornado warning. In a fire risk, you evacuate. In a tornado warning, you shelter. The two pieces of advice are functionally contradictory. The named voice that captured this contradiction for ordinary residents came from the Baca County Sheriff's Office and from the various county emergency management directors across southwest Kansas, who in their public communications on May 17th and 18th had to manage messages about both hazards. Their messaging was careful. They emphasized situational awareness, monitoring of local NWS alerts, and following county-specific instructions. What they were saying in plain English was that residents needed to be prepared for both possibilities and ready to act on either one with very short notice. What the data shows that was not said in those communications, because no county-level official will say it during an active period, is that the simultaneous risk pattern is becoming more frequent, and that the assumption of being able to deal with one hazard at a time is increasingly unreliable. The front will move through, the heat on the East Coast will break, and the Sharpe Fire will eventually be contained. But there is a number that does not go away when the weather changes. That number is what the federal firefighting system actually has available and what it will need between now and October. And how that number was reported this week tells a story about something much larger than any one fire. If you live on the East Coast and your power flickered this week, that is the same system that forced an entire Colorado town to evacuate on Sunday. The heat wave breaks when the front moves through. That same front brings wind shifts to the fire states. Do you think a wind shift in dry country with 55 miles per hour gusts makes the fire situation better or worse? The federal firefighting system in the United States is organized through the National Interagency Fire Center, which sits in Boise, Idaho. NIFC is not a single agency. It is a coordination point where the U.S. Forest Service, the Bureau of Land Management, the Bureau of Indian Affairs, the Fish and Wildlife Service, the National Park Service, the National Association of State Foresters, the U.S. Fire Administration, the National Weather Service, and the Department of Defense all share information, share resources, and share decision-making authority. When a fire grows beyond what a state can handle, NIFC is where the request for additional federal resources is routed. When the country itself is stretched, NIFC is where the call for international mutual aid originates. The national preparedness level, which NIFC has been reporting as 2 of 5 in 2026, is the metric the system uses to describe how committed those resources currently are. Most coverage of the May 15th NIFC report mentioned preparedness level 2 in passing, as if it were a reassurance. It is not a reassurance. Preparedness level 2 means that firefighting resources are not yet fully committed nationally. It does not mean conditions are safe. It does not mean the system has capacity to spare. It means that the system has not yet exhausted what it has. Preparedness level 1 is the lowest level. The system is at normal staffing with no major incidents requiring out-of-area assistance. Preparedness level 2 means initial mobilizations of resources to one or more geographic areas have begun. Level 3 means competition between geographic areas for resources is beginning. Level 4 means heavy national mobilization, with most Type 1 and Type 2 incident management teams committed. Level 5, the maximum, is the point at which national resources are fully committed and the country is formally requesting international mutual aid from Canada and Australia. The gap between Level 2 and Level 5 represents the difference between 2,000 deployed personnel and 30,000. It is the gap between a system that has slack and a system that has run out of crews, aircraft, and retardant. The number that should sit with anyone reading the NIFC report carefully is the simultaneity. The May 15th report listed preparedness level 2. The same report listed 16 uncontained large fires nationally. The same report listed nearly 2,000 personnel deployed to incidents. The same report listed 22 large fires active across 13 states. These numbers together describe a system that is sitting at level 2 by definition, while operating at a tempo that in many fire seasons would already justify level 3 thinking. The system is technically uncommitted. The reality is that resources are flowing. The structural reason for the gap between the formal level and the operational tempo is that preparedness levels are calibrated to the worst seasons in modern history. The system was designed around the catastrophic fire years of 2020, 2017, and 2018, when whole regions of the West were burning simultaneously. By that scale, May 2026 with 1.9 million acres is still moderate. The acreage is high, the fire count is high, but the resource burden is concentrated in specific geographies. So the system's overall load reads as level 2, even though specific regional dispatches are operating closer to level 3 intensity. The military aviation piece is one of the most telling indicators. The Military Airlift Firefighting Systems, known by the acronym MAFFS, is the program through which the Air National Guard provides C-130 cargo aircraft equipped with internal tanks for retardant drops when civilian air tanker capacity is insufficient. MAFS is not used in routine years. It is activated when the civilian fleet is fully committed, and additional aerial capacity is needed. NIFC has already issued a press release for 2026 MAFS mobilization. That detail did not appear in most coverage. But it is one of 3 confirmed signals in spring 2026 that the federal system is preparing for a fire load that will exceed routine resources. The aerial firefighter training piece is another. The NIFC and its partner agencies conducted emergency aerial firefighter training in spring 2026. Training of this kind is conducted when agencies anticipate a season heavy enough to justify the cost and operational tempo of an expanded aviation response. The training is not a routine event. It is a capacity-building step taken in advance of known high-risk periods. The fact that it was conducted in spring 2026, before peak season, indicates that NIFC's predictive teams were already reading the fuel moisture, drought, and weather signals as pointing to an above-normal fire year. The personnel numbers also deserve a closer look. Nearly 2,000 personnel deployed in mid-May is not a small commitment, but peak season deployments in catastrophic fire years can exceed 30,000 personnel nationally. That figure includes everyone from interagency hotshot crews to engine crews to overhead teams to dispatchers to incident command staff. The system has historically scaled to that level in years when the Western Fire Complex was burning heavily. The gap between 2,000 personnel now and 30,000 personnel at peak is roughly 28,000 additional people who would need to be mobilized, fed, housed, transported, and equipped if 2026 turns into a peak year. That mobilization is logistically possible, but it requires lead time, budget, and operational support. The retardant and equipment side is harder to scale. Aerial fire retardant, the red liquid that air tankers drop ahead of fire lines, is manufactured by a limited number of suppliers, stored at federal tanker bases, and transported on a schedule that anticipates peak season demand. When demand rises faster than expected, retardant supply can become a bottleneck. The same is true for hand crews, helicopters, engines, and water tenders. Each of those categories has a national inventory. The inventory does not expand quickly in response to a fast season. The named voice that has been most consistent on the federal capacity picture is the National Multi-Agency Coordinating Group, known as NMAC, which is the highest-level decision body within the federal fire system. NMAC's product is the national preparedness level itself, plus the geographic area predictive services outlooks. What NMAC has been saying through its publications in plain English is that 2026 is being treated as an active above-normal season that requires forward-leaning resource positioning. What the data shows that NMAC's measured language does not state explicitly is that the system is at level 2 by formal definition, while operationally already managing level 3 considerations across multiple regions. The budget situation underneath the federal fire system adds another dimension that almost no coverage has addressed. Wildfire funding and resource authorization in the United States is currently under review, with existing allocation expiring in 7 months. That means federal fire agencies are running a 76% above average fire season without confirmed full-year budget certainty on the other side of summer. The funding structure historically includes a combination of regular appropriations and emergency supplemental funding for years when fire suppression costs exceed budgeted amounts. The emergency supplementals are typically authorized after the fact, which means agencies often spend money on suppression and then wait for Congress to backfill the costs. When the political process is uncertain, the assumption that the backfill will arrive becomes less reliable. The mutual aid framework with international partners is the final piece of the system that should be understood. When the United States reaches preparedness level 5, the system can formally request resources from Canada and Australia. Canada's wildland firefighters, particularly from British Columbia, Alberta, and Ontario, have been deployed to the United States in significant numbers between 2020 and 2025. Australia's seasonal calendar is the inverse of ours, so Australian crews are often available during the U.S. fire season. The reverse is true during the Australian summer. This rotating mutual aid has been one of the structural resilience features of the global wildland fire response system over the last 2 decades. But it depends on both countries not being in peak fire load at the same time. As fire seasons in both hemispheres extend, the windows of mutual availability narrow. Inside the United States, state-level fire systems handle a substantial share of the response load before federal resources are engaged. Texas A and M Forest Service, Oklahoma Forestry Services, the Colorado Division of Fire Prevention and Control, and the Kansas Forest Service are the state agencies that respond first when fires ignite in their territories. These state systems have their own personnel, their own aircraft, their own engines, and their own coordination structures. When the state system is stretched, the request escalates to the Regional Federal Coordination Center. When the regional center is stretched, it escalates to NIFC. The preparedness level reflects the system's overall load. But by the time NIFC's load shows in the level, multiple state systems have already been working at maximum capacity for days or weeks. The capacity question is also a workforce question. Wildland firefighting is physically demanding, seasonal, and relatively low-paid for its hazard profile. Retention has been a documented challenge for federal fire crews. The interagency hotshot crews, which are the elite Type 1 crews used on the most demanding incidents, have faced staffing pressures between 2020 and 2025. The federal pay reforms passed in earlier years have helped, but the workforce structure remains a constraint. When a peak season arrives, the number of available trained crews is the binding limit, more than the number of available aircraft or trucks. The 2026 outlook from NIFC Predictive Services for the summer months suggests that above normal significant fire potential conditions are likely across the Great Basin, parts of California, and the southern high plains through summer. Above normal means the area is expected to see more large fires than the historical average. When multiple geographic areas simultaneously enter above normal classifications, the system is operating in a scenario where competition for resources becomes intense. By August, if the outlook holds, the system will likely be at preparedness level 3 or higher, with multiple regions requesting the same resources at the same time. The early season MAF's activation and aerial firefighter training are the operational signals that NIFC is preparing for this scenario. The agency's actions are the most accurate read on what NIFC's predictive teams expect. When agencies build capacity ahead of a known threat, they are signaling that they read the threat as serious. The early activation of MAFs in 2026, combined with the conduct of spring training, combined with the immediate response posture for the Sharpe Fire and the Southern Plains complex, paint a picture of a system that is bracing. The system is at level 2 in May with 1.9 million acres burned. The budget runs out in 7 months. The drought is not going away, and peak season has not started. What happens when all 4 of those things meet in August? One number tells you how close we already are to that answer. Nearly 2,000 people are working fire lines across this country right now, and peak season has not asked for a single one of them yet. NIFC confirmed level 2 while reporting 16 uncontained fires and 1.9 million acres already burned. And nobody can answer yet. At what point in the next 6 weeks does level 2 become level 3? And what will be burning when it does? The forecast for the Oklahoma, Kansas, and Colorado fire corridor through the weekend of May 23rd and 24th contains a single line that determines what the next 6 weeks will look like. No rain. The National Weather Service forecast for the corridor shows no rainfall events of consequence through at least the weekend. That fact alone is the answer to the open question. The fire weather window is not closing this week, it is staying open. A no-rain forecast in a D4 drought corridor is not a neutral fact. It is the absence of the one thing that could change the trajectory of the fire season in the near term. Rain is what breaks fuel moisture deficits. Rain is what greens up new grass and slows the rate of fuel curing. Rain is what fills the small earthen tanks ranchers use for cattle water, which means rain is what keeps grazing pressure on the grass and reduces standing fuel loads. When no rain is in the forecast, none of those mechanisms is engaged. The drought continues, the fuel continues to cure, and the fire weather windows continue to open whenever the wind picks up. The NOAA Climate Prediction. Center monthly drought outlook for the High Plains is direct. Drought will persist. The exact CPC language describes mountain snow cover as below 25% of average in most Colorado basins, which is the federal way of saying that the snowpack that should have been the source of slow spring meltwater for downstream soils simply was not there. The Colorado snowpack failure of winter 2025 to 2026 is now feeding through into the May fire weather. There is no upstream water available to fill the soil moisture deficit. The recharge that historically defines the difference between an average fire season and a difficult one did not happen. So, 2026 will run on the conditions that exist right now, with no buffer. The NIFC Predictive Services Group, which we have referenced through this script as the federal team that looks ahead at fire potential, has confirmed that fine fuels on the eastern plains reached historic dead fuel moisture minimums in April 2026. The number is in the single digits in many measurement plots. Those levels are typically seen only during the peak of fire season in late summer. The fuel reached peak season readiness 4 months ahead of schedule. That single fact reframes the entire conversation about what comes next. The fuel is not waiting for summer to become peak season fuel. The fuel is already there. Look at the 10-year average one more time. 1,085,000 acres at this date. We are at 1.9 million. The gap between those two numbers is 833,000 acres of fire that was not supposed to be on the map yet. And the calendar has 6 weeks before the system enters the season it was built to handle. 6 weeks. That is the window between mid-May and the end of June. In those 6 weeks, in a normal year, the country would expect another 800,000 acres or so to burn, bringing the total to roughly 1.8 million by the end of June. In 2026, the country has already exceeded that figure 6 weeks early. If the curve from May to June follows the same proportion above average that the year-to-date number has shown, the country could see another 1.4 million acres burn in the next 6 weeks. That would put the total at around 3.3 million acres before peak fire season begins. For perspective, the entire 2025 fire season ended at approximately 7 million acres total. The current trajectory suggests 2026 could approach that figure by the end of June, before the months that historically produce the most fire activity have even started. The named voice that has framed this trajectory most clearly is Brian Henry, the Predictive Services Manager at NIFC, whose monthly outlooks have called for above-normal significant fire potential across the southern high plains for the second consecutive month. What Henry and his team have been saying, in the measured language of federal predictive products, is that the conditions for large fire growth are in place and expected to remain in place. What the data shows that the predictive language is conservative about is that the underlying drivers are not improving. The drought outlook is for persistence. The fuel moisture is at peak season levels. The wind regime is unchanged. The system is locked into the trajectory unless something fundamental about the atmosphere shifts. The consequences of this trajectory fall on specific places with specific populations. Baca County, Colorado, with its 3,700 residents, will continue to face fire risk through the summer. Cimarron County, Oklahoma, with 2,200 residents, will continue to be the western edge of one of the densest D4 drought zones in the country. Southwest Kansas, with its 42,000 combined residents in the fire corridor counties, will continue to operate under the same level 3 of 3 extreme fire risk conditions when the next front arrives. The Texas Panhandle, with Amarillo's 314,000-person metro area, will continue to absorb the wind, the dryness, and the ignitions. What these communities can do is limited but real. Sign up for county emergency alerts before they are needed. Have a go bag prepared with documents, medications, photos, and pet supplies. No two routes out of your property if your primary road is closed. Talk to your neighbors about what you will do if a fire is reported within 30 miles upwind. Pay attention to the local NWS office's fire weather forecasts, not just the national news. Critical fire weather conditions were confirmed across parts of the southern High Plains and Great Basin through May 19, 2026. Check weather.gov/fire for your county's current status. The local NWS forecast for your county is the only forecast that tells you what your specific risk profile is. The compound nature of the threat also means that residents in fire country need to think about non-fire scenarios that can co-occur. If a tornado watch is issued in your county at the same time a red flag warning is active, you are inside two contradictory pieces of safety guidance. The federal interagency advice in those cases is to follow the watch or warning that is most imminent. A tornado warning trumps a fire watch because the tornado timeline is measured in minutes. A red flag warning trumps a tornado watch because the watch is precautionary while the red flag describes active extreme conditions. The decision-making in the moment depends on what is happening at the property, what is happening in the sky, and what the County Emergency Management Office is broadcasting. The federal communications infrastructure for emergency alerting includes the Wireless Emergency Alert System, which sends notifications to cell phones in the affected geographic area, and the Emergency Alert System, which broadcasts over radio and television. Both systems are imperfect. Cell coverage in rural fire country can be patchy. Power outages from severe weather can take out radio reception. The most reliable alerting in fire country is often the combination of NOAA weather radio, county-specific alert systems administered by emergency management offices, and direct relationships with neighbors and local fire departments. None of these channels is glamorous. All of them work when they are set up before they are needed. The Sharpe Fire's outcome on May 17th and 18th, where over 200 community members helped hold the line and no homes were lost, is a specific kind of outcome that depends on specific conditions. Volunteer community response works when the wind holds, when the equipment is available, when the local fire department is staffed, and when the fire's behavior remains within the range that ground crews can engage. If any of those conditions had failed in Baca County on that Sunday afternoon, the outcome would have been different. The infrastructure for that kind of response, the rural volunteer fire departments that anchor small-town emergency response across the southern High Plains, depends on funding, equipment, and volunteer retention. All three of those inputs have been under pressure for years. The federal recognition of this infrastructure is captured in programs like the Volunteer Fire Assistance Program, administered by the U.S. Forest Service, which provides matching grants and equipment to rural volunteer fire departments. The program is small relative to the need. Many rural departments operate engines that are decades old with limited water capacity in service areas that span hundreds of square miles. The Sharpe Fire response was successful in part because the local departments, the community volunteers, and the state and federal crews integrated effectively. That kind of integration is possible because of years of relationships, drills, and mutual aid agreements. It cannot be assembled at the last minute. The next test of the Southern High Plains fire system is likely to come within the next 10 days. The cold front that is currently moving through the eastern United States will eventually be replaced by another system. The wind regime of late May into early June typically includes multiple cold front passages, each one capable of generating fire weather days in the corridor. The pattern from May 15th through May 18th, with humidity dropping into the single digits and wind gusts reaching the 50s, will recur. The fuel will not become less ready. The drought will not improve. The system will be tested again. Beyond the immediate 10-day window, the calendar pushes toward the climatological peak of Central Plains fire activity in late June and early July, before the summer monsoon pattern shifts the southwestern fire weather pattern toward the desert southwest. The southern High Plains tends to see its highest fire activity in spring and early summer before monsoon moisture begins to arrive from Mexico in July. So the fire window for this corridor is essentially open from now through late June, with the most dangerous days clustering on the days when cold fronts pass through. What the data shows that the public conversation has not absorbed is that 1.9 million acres is not the peak. It is the baseline from which the rest of 2026 will be calculated. Every additional fire that ignites in the corridor between now and August adds to the total. Every additional acre that burns in the West, in California, in the Pacific Northwest, in the Rockies, adds to the total. The figure that lands at the end of October is the sum of every fire from January through the end of fire season. We are not measuring the peak, we are measuring the starting line. The pattern of compound multi-hazard events that we documented in the May 17th and 18th window is also unlikely to be unique to that weekend. The same atmospheric setup with a ridge over the east and a slow-moving cold front in the plains can recur multiple times across a single fire season. Each occurrence generates the same combination of fire weather, severe weather, and heat. As the calendar moves into June and July, the severe weather component will likely shift northward, but the fire weather component will remain active in the southern high plains until significant moisture arrives. The federal fire system, the state fire systems, the volunteer fire departments, the emergency management offices, and the affected communities will all be doing their work through this period. The system has experience with above-normal seasons. The question is whether 2026 stays within the range of seasons the system has historically managed, or whether it pushes into a category that exceeds the historical envelope. The answer to that question depends on what happens with the drought, what happens with the wind, what happens with the human ignitions, and what happens with the budget. None of those inputs is fully predictable. All of them point, right now, in the same direction. Here is what to watch between now and Friday, May 22nd. If you are in Texas, Oklahoma, Kansas, Colorado, or New Mexico, the most important thing you can do right now is sign up for your county's emergency alert system before you need it. In Baca County, Colorado, that is through the Baca County Office of Emergency Management. In Southwest Kansas, contact your county emergency management office directly. Do not wait for a warning to find out how warnings reach you. If you live in grass fire country, your evacuation window can be as little as 15 minutes. Not from when you see flames, from when a fire ignites nearby. Have a bag ready. Have your medications, documents, and your pet's supplies in one place. If you see smoke, do not wait for an official order. Leave. Do not burn anything outdoors right now. The NWS confirmed humidity at 4% in the Texas Panhandle on May 17th and 18th. A single spark in those conditions becomes a problem faster than any crew can respond. Outdoor burning of trash, brush piles, or agricultural waste is the source of a roughly 30% of human-caused wildfires in the Central Plains. Even tasks that seem unrelated to fire, like welding, grinding metal, or pulling a trailer with a dragging chain, can produce sparks capable of igniting cured grass. Mechanical equipment in dry conditions is an ignition source. Cigarettes thrown from a vehicle window are an ignition source. Vehicles parked over tall dry grass are an ignition source because the catalytic converter on the underside of the vehicle reaches temperatures hot enough to ignite the grass. Every one of those everyday actions has caused a wildfire in this corridor in the 2021 through 2025 fire seasons. Check current red flag warnings for your specific county at weather.gov/fire, not the national map. The humidity and wind data for your county is what matters, not the statewide picture. Critical fire weather conditions are continuing across parts of the southern High Plains and Great Basin as of May 19th. Check your local NWS office for the latest. Check INCIWeb at inciweb.wildfire.gov for active fire locations and current containment status. This is the official federal database updated by incident teams on the ground. Check the NIFC National Situation Report every Friday at nifc.gov. The May 22nd update will show whether the national preparedness level has moved and what the updated acreage totals show. If you need to travel through southeastern Colorado, check Highway 287 status at cautrip.org before you go. The highway was closed Monday due to smoke from the Sharpe Fire and has since reopened, but conditions in that corridor remain active and can change. Watch whether the cold front's passage drops humidity back to single digits in Kansas and Oklahoma on Tuesday, May 19th and Wednesday, May 20th. If it does and fuel conditions remain at D4 drought levels, the fire weather window stays open. Watch the NWS forecast. Wednesday, May 20th for any new fire weather watches or red flag warning issuance. New warnings after Tuesday would confirm the fire corridor remains active through midweek. Watch the NIFC Friday, May 22nd report for any change in the national preparedness level. If it moves from 2 to 3, that is the first concrete indicator the system is beginning to stretch toward its capacity limits. American wildfires had burned 1,918,424 acres, which is 76% above the 10-year average for the same date. The Sharpe Fire crossed 2 state lines, triggered a state of disaster emergency in Colorado, and forced an entire county to evacuate. The National Weather Service confirmed extreme fire weather, EF3 capable tornadoes, flash flooding, and a record early season heat wave, all produced by the same weather system, all confirmed in the same official forecast on the same day. A Sunday afternoon in Campo, Colorado, where the emergency alert said leave immediately and people packed what they could and drove out on a highway that would close behind them an hour later. And then over 200 people from that same community came back, not to their homes, but to the fire line, and they held it through the night so their neighbors could return in the morning. No homes were lost. A rancher in Cimarron County watched the smoke column rise on Friday afternoon and made the call to move livestock west before the wind shifted. A volunteer firefighter from Springfield, Colorado, drove south through Highway 287 toward Campo, while other vehicles were driving north away from it. A family in Baca County packed photos, medications, and a dog crate into the back of a pickup and waited for the order they had practiced for but hoped would never come. This is not a story about one fire in Oklahoma that crossed into Colorado. This is a story about a country that is burning 76% faster than the 10-year average before its fire season has started. With the drought locked in, the fuel cured to peak season readiness 4 months early, and 6 weeks still to go before August arrives. The people who held that fire line near Campo on Sunday night knew exactly what they were up against. They read the same conditions, they saw the same smoke. The least the rest of us can do is look at the same data they were looking at and take it seriously before the next fire starts.